All right, so Bohr diagrams. What do you guys remember from grade 9? What do you remember? Yes? Not much, really. That's fine. So let's just start by talking about the periods. Now, how many elements are in the first period? Remember, the periods are your left to right, the rows. So how many elements are in the first period? Yeah, there's 2, right? There's 2. How many are in the second period?
8.
There's 8. How many are in the third period?
8.
8 yet again. So in grade 9, your teacher probably said, for Bohr diagrams, you should use the 2, 8, 8 rule, right? Now, what is the 2, 8, 8 rule? Do you guys remember what is the 2, 8, 8 rule? Yeah?
The number of rooms are in the outer.
Yes, but not just the outer ring. Yeah?
Would it be like the number of electrons in like each orbital?
Yeah, the maximum number of electrons that can fill that orbital or that shell. So in the first shell, right, if I was looking at the first shell here, how many electrons can we fit in the first shell?
2.
There's 2, right? Because there's only 2 elements in the first period. Now, I like you to pair your electrons up. So you'll fill all the single openings first, and then you'll pair them up after. I'll show you a little chart of what that will look like afterwards. But in your first shell, there can be only 2. And once you have 2 in there, if you have to draw a third, you're going to have to draw a new shell. So how many can go in the next orbital? You can have up to 8, right? So up to 8. So I like to draw them like this. 1, 2, 3, 4, 5, 6, 7, 8. Now, if I wanted to add another electron, what do I need to do? I have to draw another orbital. Right? I'd have to draw another orbital to add another electron. Same thing in this orbital. You'll fill it up 1, 2, 3, 4, 5, 6, 7, and 8. Does that make sense? Okay, so let's do a couple examples here of what I expect you to do. Because I want you to do the first 18 elements. And for some of you, this is going to be super boring and tedious. I apologize. However, it is a necessary evil. We will be making reference to this chart quite a bit when we talk about periodic table trends and when we talk about ions. So, let's look at a couple examples. Let's keep it really simple to start. Let's do lithium. So, what is the atomic number of lithium? Yeah. 3. Right, from my lesson on Friday, you should know this. What is the mass of lithium on your periodic tables? Yeah?
It's 6.94 to 7.
Yes, 6.94, but we will round that up to 7. So how many protons are there in an atom of lithium? Yeah?
3.
There's 3. So our number of protons will be 3, right? The number of protons determines what element you have, so that will be lithium, right, if it has 3 protons. The number of electrons is how many? In a neutral atom of, let's hear for someone else, in a neutral atom, how many will that be? If it has the same number of positives and negatives, how many are we going to have?
3.
Excellent, we're going to have 3. 3 electrons, and then lastly, what is our number of neutrons? Yep.
4.
4. How did you find that?
So you round the atomic mass, which is 7, and then you subtract 7 from the atomic number, or the number of protons, which would be 4.
Excellent. So for those of you that did not do the assignment from Friday, the mass of your atom is your nucleus, right? The electrons, doesn't matter. They weigh almost nothing, right? They weigh 1/1837th of an AMU. So your nucleus consists of your protons and neutrons. If we remove our protons, we're left with our neutrons. So we have an atomic mass of 7, we round that up to 7, and that is our nucleus. If we subtract our protons, we are left with our neutrons. So for each of your elements on that Bohr diagram sheet, I do want you to list the number of protons and I want you to list the number of neutrons. Now let's draw the Bohr diagram. So let's illustrate how many electrons we have. In grade 9, you may have drawn like a big nucleus and you put the number of protons and neutrons in there. Your sheets are a little too small to do that, so you can just write the number of protons and neutrons in the corner. Your nucleus can just be a little dot. And let's now add our electrons. So what if I did that? Is that right? What do you think? Everyone's shaking their head no. Why is that wrong? Yep.
The first orbital can only have 2 electrons.
Excellent. The first orbital, remember that 288 rule, the first period only has 2 elements. So it will only have 2 dots. And then afterwards, how are we going to add that third electron?
Another orbital.
We have to add another electron orbital. Let's do one more example and then I'll let you guys work. It seems like most of you remember grade 9 quite well. And if you don't, there's a pretty good benefit of only having 5 students in the room. I can pretty much be your personal tutor, right? So let's do one more example. Let's look at something a little larger. Let's do like magnesium. Why not? Magnesium has an atomic mass of what? Yep.
24.
24. So how many protons do we have in magnesium?
12.
We have 12. Same as your atomic number. In a neutral atom, that means we're also going to have 12 electrons. And our number of neutrons is going to be 24 minus 12, which is 12. All right, so now for this one again, let's draw the Bohr diagram. So we have how many electrons?
12.
We have 12 electrons. So we're going to fill in 1, 2, and then what do we need to do now? We have to add another orbital. We're going to put in 1, 2, 3, 4, 5, 6, 7, 8 for 10 electrons total. And again now, I must add another orbital in order to add our last 2 electrons. So that's magnesium. Now, I'm going to put up an outline with numbers on it showing you where I would like you to add those electrons. The important thing is your electrons will fill up these single spaces and then they will pair up. I know this seems rather particular to do, however in grade 12 chemistry it will make a lot more sense. So now let's do a random outline to show you where those electrons kind of should go, because I find this is the biggest mistake. Students will just draw electrons willy-nilly. I do want you to put them in a very specific order. So in your first shell, they will pair up. In your second shell, they will go like this, 3, 4, 5, 6. And once you've filled each of those spots with a single electron, then you will go 7, 8, 9, and 10. And then in your third shell, you will have the 11th, 12th, 13th, 14th, and once all of those single spots are filled, you will start to pair them up again. 15th, 16th, 17th, and 18th. So this should be review. If this is something you did not learn last year, let me know. I can work through a couple more examples with you. We can go through this nice and slowly. But I expect you for each of those boxes to fill in the Bohr diagram. And in one of the corners, it doesn't matter which one, I want you to list the number of protons and I want you to list the number of neutrons.
Just in one of them? Or in all of them?
In all of them.
Okay.
In all of them. Any other questions? Okay, get to work.